Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Syami Hadi bin Nasaruddin. I'm from J4EM1104E and my metric number is 2019400618. So for today, I will make a thermofluid lab, which is the T3 experiment, and the title is Determination of Jet Velocity and the Nozzle Efficiency. So without wasting my time, let's check this video. Bismillahirrahmanirrahim. So now we will start with the objective of the T3 experiment, which is the determination of the jet velocity and the nozzle efficiency. So for the objective of the experiment is to study the characteristic of nozzle and the parameter that affect its efficiency. So next is the safety procedure, and of course, first of all, switch off all equipment after experiment and wear safety boot and lab coat. Now I will go to the apparatus and procedure. So for the apparatus, we will have main component. First is the chamber. As we can see, the chamber pressure, this one. Next is the nozzle. We can see there is two nozzle. First at this point and then this point, but the nozzle that we will use at this point. Next is the pressure gauge. As we can see, the pressure gauge, we have two, the chamber pressure and the inlet pressure. And next is the thermometer. We can see this one T1 and this is the T2. T1 also at this point. And next is the flow meter, which is the mass flow rate. And next is the valve. We can see the control valve, chamber pressure control valve, diverter valve, relay valve, and at this one we'll call the needle valve. So next we will go to the procedure. First of all, we will switch on the experiment apparatus, and next we will close the air inlet control valve and open the chamber pressure control valve at this point. And then before we make the nozzle, we must check the micrometer dial has been corrected in 0 and that the curtilinear load and the deflection graph is available. So next is unscrew the kernel nut at the top right hand end of the chamber, which is this one, micrometer nut. We will unscrew it and get the nozzle out to change the nozzle. We have 5 nozzle, which is nozzle 1, nozzle 2, nozzle 3, nozzle 4 and the nozzle 5, and each nozzle have a different type of size. And then after we withdraw the nozzle and assemble the nozzle one to the unit, then we will turn the diverter valve handle to the upward position. This is the diverter valve. When we get in the nozzle, the diverter valve will go to first at this point and then this point. So the diverter valve will go upward, will go to this point. Then when the pressure has go into this point, we will turn the diverter. Then we will open the chamber pressure control valve fully open and adjust the inlet control, which is the air inlet control valve, to give the constant air inlet pressure to 600 kPa gauge. When we will control the control valve air inlet to make sure the inlet pressure is 600 kPa pressure. And next, we will rotate the micrometer adjustment screw. The micrometer adjustment screw is this point too. Then we will make at this point the micrometer null nut. So when we adjust it, we will make sure the voltmeter is 0.5 and this point we will make it to 0 point. And then after we will make sure the voltmeter is 0.5 and the micrometer null is 0. Then we will record the pressure, the temperature, AMS flow rate and the dial reading. And after we finish record the pressure, temperature, AMS flow rate and the dial reading, then we will increase the chamber pressure to about 100 kPa gauge and repeat the above step. So after we take the first result, then we will increase the pressure of the control valve at the chamber pressure until it 100 kPa, and then we record also the pressure, and then we will continue repeat the experiment and make sure the inlet pressure remain constant when we repeat the test at the other chamber pressure. And after we finish it, we will repeat the whole test from the first step until the end step with the different nozzle, and which one the nozzle 2, nozzle 3, nozzle 4 and the nozzle 5. So that's it for the objective, apparatus, safety procedure and the procedure. Now for the calculation. First, we will do the overall pressure ratio. The overall pressure ratio, which is the formula is P2 over P1. And the P2 and the P1 we will use the absolute pressure. And then for the mass flow rate, we will use the formula is rho area exit times V to S. The V to S is the Z velocity. I'm sorry, the V to S is the nozzle velocity. And then for the rho, we will use the formula for the rho is the P2 over R times T1. R is the 0.287. Then we will move to the nozzle velocity, which is V to S. V to S is 2000 K over K minus 1 times R times T1 times 1 minus RP power of K minus 1 over K. The K is the 1.4. Then after that, for the area exit, the formula is throat area times pi d square over 4. And then we will move to the jet velocity. Jet velocity is equal to force over mass flow rate. For the force, we will take from the graph, and the mass flow rate we will use the observed mass flow rate, not the corrected one. And then we will move to the nozzle efficiency. Nozzle efficiency is V to A power of 2 over V to S power of 2 times 100. Now we will start the calculation for the nozzle one. So we will start to do the data set for the T3 experiment, which is the determination of nozzle efficiency. So first we will make the table. First, for the first, we will put the observation, and test combo. Then after that, we will input the inlet pressure, inlet temperature, chamber pressure, chamber temperature, cantilever deflection, and a mass flow rate. So this thing we will get into the data set T3, which is given by the lecturer. So after we done for the inlet pressure, and then we will move to the derived result. So we will do a mass flow rate, inlet pressure for the absolute, inlet temperature absolute, chamber pressure absolute, chamber temperature absolute, and overall pressure ratio, impel or nozzle reaction force, jet velocity, nozzle efficiency, and nozzle velocity. So for the formula, I have explained in the calculation part. Then after we finish the table for the nozzle 5 for the T3 experiment, then we will go to the graph. So we will use the scatter with smooth line. First we will do the MS flow rate, which is the corrected one, versus the overall pressure ratio. So the name of the table, we will put mass flow rate, so this is the nozzle 5. So for the X series, we will take the overall pressure ratio, the X series we will take the MS flow rate. Then the series Y we will take the overall pressure ratio. This is the first we'll take overall pressure ratio, then we'll take the MS flow rate. Alright, so this is the table for the first. So this is the mass flow rate over pressure ratio. The above one will be the pressure ratio, and the x-axis will be the mass flow rate, kg over s. Alright, next we will do the table for the nozzle 5, and the series X we will take same as before, the overall pressure ratio, and the series Y value we will take the nozzle efficiency. So the graph will be like this. So this is the nozzle efficiency over pressure ratio. So this one we will nozzle efficiency percentage. Alright, so this is the for the nozzle 5. Then for the others we will done too. This is the table for the nozzle 2, and this is the graph for the nozzle 2, and this one is the nozzle 3 table, and this is the nozzle 3 graph. So that is for the table and result. So lastly is the conclusion of the experiment. So the conclusion for T3 experiment, which is the title is the determination of nozzle efficiency. So the conclusion first is the result and the outcome is successfully obtained. And next is the objective of the experiment, which is to study the characteristic of nozzle and the parameter that affect its efficiency is also obtained successfully. So next is the experimental result and the theoretical result. As we can see in this video, the air mass flow rate for the observed and the corrector is a little bit different, but it not a big difference, but it about 0.02 plus or 0.03 plus. So the difference is less before, so the difference is less. So next is for the so next is for the possible error of this experiment. So for me, I think the possible error for this experiment is in the procedure where we need to make the voltmeter to 0.5. So as we can see in the lecture video, the apparatus will not show the exact voltmeter, which is the 0.5, because the needle is not stable, so there will be an error in the result. So lastly is the application. So for this experiment application, I think it's the pressure application, because we can see there is many pressure application, such as we can see the jet velocity and the nozzle. So it's same with the F3 experiment, which is the F3, which is the impact of a jet. So the application about the same, but the concept is a little bit different. So that's it for the conclusion.